Welcome to this tutorial in which we will do a walkthrough of the walt.id Enterprise Stack APIs. We will set up the Enterprise Stack to be an issuer, to issue a credential, a wallet to receive that credential, optionally with a status attribute for revocation. Then we will set up a verifier to then request and verify the credential we issued previously into our enterprise wallet. My name is Tamino from walt.id, and let's now get started. First, you will need to clone the walt.id Quickstart repository. You can find it on our GitHub, and so you can simply clone it here right onto your machine. Note that you need to be an Enterprise Stack customer and need to have access to our private Enterprise Stack images to use this Quickstart. Now, I have already cloned the walt.id Enterprise Quickstart onto my machine and have it here open in my terminal. I also have another terminal where I can then access the configuration files which are inside of the walt.id Enterprise Stack Quickstart. So if we quickly look here, we can find a feature configuration where we can enable or disable different types of features, which are also mentioned in the documentation. And in the super admin registration conf, which will be the most important file for this tutorial, we will find our super admin token, which we can also change, of course, to then initialize our root account, with which we then can start onboarding other users or create API keys and generally configure the enterprise stack services. Now let's jump back to the tutorial. So we cloned the repo, we have it on our machine. I also have my Docker token added so I can run the enterprise stack. And so now I will simply run the API. Back in my terminal, I will execute the run command. And this should be bringing up the walt.id Enterprise API under the localhost 3000. So the application is now running and we can access it. So back here in my browser, I will go to Enterprise localhost 3000. And here we should then find the walt.id Enterprise API. Now, right now, we can't do much with it. And so the first thing we will need to do, as already mentioned previously, we need to create ourselves a super admin user. Now, we have the specific endpoint, which is super admin create by token. And here we need to provide our super admin token, which we can find in the configuration file we saw previously. If I go back to my terminal, to my other window, and here in the config files, I will quickly access the super admin registration conf. Now here I will be copying out my token provided here and register. With that, we now have our super admin user. And so what we can do is now log in with that user. So here in the account /email pass endpoint, we can now provide our email and password, which we also find in this file. So I will provide the email, I will provide the password, and I will execute this and log in as a super admin user. Now, normally you wouldn't want to use the super admin for regular operations, which is why, as a first step, we will create an API key for our organization. Now, we didn't create yet an organization, and so that's what we will do first. So going back here to our tutorial, we logged in, authenticated. So normally you would authenticate by providing it as a bearer token, but we use the Swagger interface, so we don't need to do that. So, and now, as I said, we need to create an organization. And to do so, we can use this admin/organizations endpoint. And I will be now just copying out here this body. Now we will be creating a walt.id organization. And what's interesting here when we execute this to create our first organization is that we will now get a subdomain for that particular organization based on the ID we provided. And so from now on, all our operations should be done not from enterprise.localhost, but from the organization that we are accessing. Also important, generally, when you have an enterprise stack and you create your organization, you should only ever have one organization. Now, if you have a B2B business model, or if you also want to onboard other businesses to the enterprise stack, you can use the tenant system for that. So you basically create an organization for your organization, and then all the other organizations which are customer of yours become a tenant under your organization. So now we switch to the walt.id organization, and what we can now do is go ahead and create our API key. So what we will go to the API keys create endpoint in the Swagger documentation and now create here our API key. I will provide a name for it, also an expiration date. And now what's quite interesting is this target parameter, which we will now see in almost all operations we are doing. And basically, it's a path of the resource, like a unique identifier that we are assigning every time we are creating a new resource in the enterprise stack. Now, a resource can be an organization, it can be a tenant, a service like the issuer service, an API key like we just now see here. And so we can give unique names for all of these different resources. Although specific parts of that unique ID are already predefined, because it's at the same time also a display of the hierarchical structure of the different resources. So when we quickly look here at this overview, we see here at the top the organization. So this is the root, then the tenant, which is already one layer down, and then the services, which are again a layer down of the second layer. So it's on a third level. And when we now look at the target, this is also reflected. So we're starting here at walt.id, which is this organization level. So the first thing in the target is walt.id. Now the API key will be part of that walt.id organization. And so here, which is the second part now, of this target parameter, which we can define. So the first one is already defined because we created the walt.id organization, but the next section we can define. And this is then basically the unique identifier of our choosing for that specific key we are about to create. So in this instance here, we will be using my API key as the identifier. And so when we execute this now, we see that we created an API key. Now I will save that for later reference. So now we have our API key. However, by default, the API key can't do much because it doesn't yet have any roles or permissions associated with it. And that's why we also need to assign the API key a role so it actually can do something. Now, when we quickly take a look here at the slide, we can see examples of different types of roles, like the KMS manager role, a walt.id tenant role. And here we have different types of permissions associated with this specific role. Now, as we created the organization in the beginning, there was automatically also a role created, an admin role for that specific organization, which is basically using this all wildcard permission so that the user or the API key will be able to do all types of operations in a specific organization. And so that's what we will be now doing. We will assign ourselves, so our key API key, that admin role. We will go to this API key assign endpoint and now define in the body our API key. And then in the target, we will set the role target, so the role ID, which is walt.id, which is our organization, and then admin, which is by default created. So when we execute this, we now have attached that role to the API key. And so we can now from now on use that API key. And so now that we have our API key, we can go on with building out our structures to enable issuance, a wallet, and verification. And to do so, the first thing we will need to create under now our organization is our tenant, our first tenant. And so we will go to this tenant/create endpoint in the Swagger documentation and then create our first tenant. Now in the body, we will provide a name for the tenant, and then we will specify again our target, which is that we create in our walt.id organization a tenant with the ID tenant1. When we execute this, we now created our first tenant. And now as a next step, we come to the services, which then enable the various digital ID features like an issuer, a verifier, and a wallet. Now, as we've designed the services for the walt.id enterprise stack, we try to make as little assumptions as possible about how you would want to use the walt.id enterprise stack to build out different use cases. And that's why we build out the services like Lego blocks. So you can combine them based on different use cases to get the required functionality you need. And so for our use case, where we want to issue a W3C verifiable credential, where the issuer and the holder has a DID, and it also has a revocation status, we will be creating the following services. We will need a KMS service that manages the keys of the issuer, and then also one for the wallet. We will need a DID service that can create DIDs based on our keys managed via the KMS. Now, the DID service itself won't store the keys, and so we will also need a DID store to then store the created key, the created DIDs via the DID service. And then we need an issuer service, which basically leverages the other services like KMS service, DID service, and so on to then issue credentials. And then we also need the Credential Status service that then connects to the issuer service to enable revocation for our credential. Then we have the Verifier service, the wallet service, and the Credential Store service, which will be used by the wallet service to store the credentials we receive. Now, this is just one setup now for W3C Verifiable Credentials with DIDs, because in case you don't need DIDs and you just use keys, you don't need these services, or if you don't need a Credential Status, you also don't need this specific service. Though for our use case, we will be now creating these services. And first, we will start off with a KMS service. Here, we will go to our services create endpoint, which we'll be using quite a few times in this session now, to create our first service, which is the KMS. So in the body, we already have the type set to KMS. And so the only thing we need to provide here is the target. And as we can see, we now build up this hierarchy where we have already the walt.id organization, we've created a tenant1, and inside of the tenant1, we can now define our KMS. We will call it now KMS1. So when we create this, we now have our service. Now, what's special here, we just now created a KMS using the default settings, which means the storage of the enterprise stack, so the database, the MongoDB database, will be used to store the keys. This is a great solution when you do demos or POCs, but for production environments, it's recommended to use an external KMS. And so here are different integrations available for HashiCorp Vault, Oracle, Azure, and others. And so you could set up here the KMS that it uses one of these external integrations for the key storage. So now let's use that KMS service and create our first key. I will go to the keys generate endpoint under the KMS Service API and now create my first key. I will be creating an ED25519 key and I will call it key 1. And here we can see again the hierarchy. where we now create a resource inside of the KMS we just created. So let's execute this and we get back our key. So now let's also create the DID service so we can create our DID. We will be going back to our services create endpoint and now create our DID service. So we specify in the target our DID service ID, and in the body we will specify the type, which is in this case DID. Now we have our DID service, and so we also need to create a DID store so we can then actually store and persist the DID documents we create via the DID service. So we will stay at the services create endpoint. I will provide now in the target the ID for the DID store, in the body the type of the service, and so we can also create that. Now what we need to do is link the DID store to the DID service so that every time we create a DID via the DID service, it is stored in the attached DID store. And so what we will do, we go to the DID service API, DID's dependencies add endpoint, and now add our created DID store to that DID service. So in the target, we specify the DID service we want to do this operation in, and in the body, we specify the ID of our DID store. Let's create that, and here we see now we have attached this DID store to the DID service. And so now we can create our DID key. And so we will be using also another endpoint of the DID service, the create key endpoint. Here in the top, we will in our target specify the DID service we want to do this operation in. And then here in the body, we will specify first the key ID we want to use to generate that DID based on. Now, here we can see we created our DID key, and here we also have the document. So what we could do now is check out the DID store to see if this DID was stored. So we can go to the DID store service API and list our DIDs. So here in the target, we provide our DID store ID, execute, and here we will see our DID that we just created via the DID service. Then, as a next step, we will need to create our wallet service. And also here, the wallet service does need a few other services to do its work in its full feature set, because you could also create a wallet service and then just use the exchange endpoints and pass in raw keys, for example, to receive or present a credential and then store these credentials in your own system. But if you want to let the enterprise stack do all the storing and the handling of the keys, you will need a wallet with a KMS service, a DID service, a DID store, and a Credential Store. And for this wallet, because there are so many different dependency services that you need to create, we have a helper endpoint, which is this wallet, this init wallet endpoint. And so when we go quickly here, first of all, need to specify again the target, so the ID of the wallet we want to create. And then in the body, we specify the different services that should be created with this call. And so we see we create a KMS service. We also give it a specific name. We create a key in that KMS service. So we already created a key, but this was in the KMS for the issuer. And this is then for the wallet. We create a DID service. We also create a DID within the DID service, which is then stored in the DID store, which we also create. And the DID we create is of type key, which will then be based on this key, which we here created. And then we also create a credential store, so we can then store the credentials. Now, when we execute this, we now created all of these different dependency services and attached them. So basically, you could do the same thing using this services create endpoint we used earlier, and then basically attach all of these services to the wallet. But now we just did everything in one go with this init endpoint. So now we have our wallet, and let's now go ahead and create our Credential Status service, which we will be then using from the issuer service to then issue a credential with a revocation status. And so here, let's go again to our services, create endpoint. We will create our status service using this ID. And in the body, we will now specify the credential status as a type. And then here we need to provide a configuration for an external registry, which will be used to then host the status credentials. Now, we offer here AWS S3, Azure, and also Google Cloud Storage. I will be using Azure here for this demo, but you can choose whatever fits best, or you just leave it out. So it's not a must. You can also try it out later and go on with the next section. So I now provided the secrets and are now creating this specific service. So now we have the status service set up. And so the first thing we will need to do before we then can move on to the issuance and create the issuer service, we will need to create a statusless credential configuration, which will then be used by the issuer to create a status entry. And so here we also support different types of standards on which you can base the status credential. We will be using the statusless 2021 standard, and we will create a configuration with the purpose of revocation. And we have these two statuses, which are basically revoked and not revoked. And we will now go to this endpoint to create our status credential configuration. We will first specify our status service here in the target and our config ID, which is config1. And in the body, we will provide the status information. Now here I need to now get the DID, which we created earlier. So as the statusless credential is basically another W3C Verifiable Credential, which will be issued and signed, we will need to provide a DID and a key. So a key to sign the credential and the related DID. Let's execute this. We created our first config, and now we can move on to the issuer service and the creation of the issuer service. So we will go again to our services create endpoint. This time we will create the issuer. In the body, we will provide, first of all, the type, so issuer, the base URL, which should reflect our URL where the enterprise stack is hosted. Now I refreshed, so let's quickly do that again. Base URL is basically where the enterprise stack is hosted, so walt.id enterprise local host in that instance. Then we have our KMS, then the token ID that should be associated with this issuer. So we have our key here that is signing during the credential exchange. And then we have supported credential types, which are basically the credentials this issuer is able to issue. Now, we just configure one credential here, which is the university degree, a W3C Verifiable Credential. That we can then issue later, but you could also configure to issue SD.VCs or MDL or other credential types. So we go ahead here and now create our issuer. With that created, we need to create our last service, which is our verifier. So here we will provide again the verifier, so our ID here, and in the body we will specify the details like the type, the base URL, which is also again the same as with the issuer. And here the metadata config, which is optional, where we can set a specific name or logo for that verifier. So now that we also have the verifier created, we can go ahead and now issue our credential. Now we will do with revocation. And so First of all, we will need to go to the credentials issue endpoint of the verifier service. The issuer service. Here, so we don't need a status callback URI in that instance, no request ID, and we just need to provide our target, which is the issuer we created earlier, and then we have our body, which is the actual credential that we want to issue. Now, let's quickly take a look here. So first of all, we have our key again, which we created in the beginning in our KMS1. Then we have our did. So this is not our actual did. So I need to replace that here. Let's provide it here. Then we have credential configuration ID, which is what we've set up as we set up the issuer. So we configured this to be available. And then we have the actual credential data. So a regular W3C Verifiable Credential data set with the context, the ID, which will be replaced later by a mapping function, where you can also learn more about in the documentation about how these work. Then we have our type, which is university degree. We have our issuer, which will also be replaced by a data function. So it will be the did of the issuer. So this right here. Then we have the issuance date, which will be replaced by the actual date when this is issued, also by a mapping function. Then the credential subject. Here we have ID, which is a did. So this will also be replaced by a data function, which will be then the did of our wallet. And then the degree. And here, interesting for those who use or want to use the Credential Status service and do a revocation. Here we provide the status object with a status credential config, which points to the configuration we set up earlier, and provide an additional status to set this credential as not revoked. And so basically this will then be used to communicate with the status credential status service of the enterprise stack to create a status list entry and then host the status credential with this updated status list entry in the configured registry, so that verifiers and wallets and other parties can access it later when they inspect the credential. And then right here at the bottom, after this mapping object, we have the authentication method, which we have set to pre-authorized, which means the user, so the receiver of this credential, doesn't need to authorize or authenticate, or they can receive the credential. So let's execute this, and we get back our OpenID for VCI offer URL. Now this we can now take, and now in a typical sense, when you have a wallet, you would probably render this as a QR code, and so the wallet can scan it, or you provide it as an embedded link or direct link, which opens the wallet, and then the wallet passes this. But as we are here now operating just on the API level, we will go to our receive endpoint of the wallet. Let's go to the receive endpoint, and then we provide, first of all, so our offer, which we get back from the issuer. Then we need our target, which is our wallet, so the wallet that should receive the credential. And then we have our key reference and did reference, which are basically the key and the did we created as we called this wallet init endpoint, where we created all of the dependency services in one go, which we now use here to bind this credential to this key. So let's execute, and there we have it. So we just received the W3C Verifiable Credential. And what we can do now is go to the Credential Store service API and list our credentials. So here we need to provide our Credential Store ID. We quickly copy out here this ID, and then let's see what we have. So, okay, then let's use that and update here, add our walt.id tenant 1 in front of it, and then we will get back a list of credentials, and this is our credential which we just issued via the issuer. So let's do now a verification, and so we use our Verifier service with Credential Status. So we go first of all to our credentials verify endpoint. Then here we need to provide our target. The other information we don't need to provide in this instance, and in the body we will provide the following. So we will request a university degree, which we issued in this .wc JSON format, which is basically the W3C Verifiable Credential format. And we will apply a specific policy next to the, by default, applied signature policy, which is called the Credential Status policy. And what we will check here is first, okay, it's a W3C Verifiable Credential. So the status credential, it has a purpose of revocation, and the value is 0. So basically it's not revoked, and it's of type status list 2021. And so when we execute this, we get another OpenID for BP authorization request. And now we need to present it via the wallet. So normally, so we now know that we only have one credential in the wallet, and so we can basically simply present that credential, knowing that this matches the specific request as we formulated ourselves. But in the real world, we wouldn't know that. So we would need to first decode this, what I just did, decode this request, and get this presentation definition URI here. Now, when we open this, we get this presentation definition, which basically describes to the wallet which type of credential the verifier requests. And we see here, yeah, it's a university degree. And this we can now use when we go back to our Credential Status, Credential Store. And we have this list endpoint, which gives us all the credentials. But we also have this document schema endpoint, where we can now provide this constraints here. So in this fields array, we copy out here this object, paste it here, and in the target, provide our store. And now we get back all the credentials that match that presentation definition. And so we can use it to figure out, okay, which credential, or do we actually have a credential that matches what the verifier wants? Now you would present it in the regular world to user via user interface and ask them if they want to present it. And if they give the consent, you would go ahead and execute the APIs. And so we get now this ID here of the credential. And so we found the matching credential, and now we can present it. So let's go to the credentials present endpoint, and here let's quickly copy out this body. Then we provide our credential ID. So here we could also provide disclosures in case this would be an SD shot, but it isn't. So there are no disclosures we can provide. So we simply provide here the credential ID. And then of course in the target, we need to provide the wallet, and also we need to add here the request URL, the key reference and the DID reference. So here we have again our key, our DID from previously, and here in the request URL we get what we got from the verifier API, and execute. So now we presented the credential. Let's go back to the verifier and check if everything passed, if the policies we applied passed, and if the credential is not revoked. And so let's go back to the verifier, to sessions view, and here we now provide the target, so the session, which we can also find here when we search for the state value. Copy out that information, provide it here in the target. And so we get back to results. We have here the VP token, which is the credential we presented. So if we quickly go here, paste that in, we see that, so this is basically this wrapper credential, which we have for W3C Verifiable Credentials, a wrapper credential that is signed by the holder, proving key ownership. So we have this verifiable presentation, which is this wrapper credential, and inside we have the verifiable credential that was presented. And so when we take out this, we see that this is actually the university degree that we issued in the beginning. And here we can also see the status information and where the status list credential, the status credential is hosted. Let's now go back and see if all the verification results passed. So generally it was a success. So the signature policy was checked and valid for both the VP and the verifiable presentation, this Repo credential, and the actual credential, so the university degree. And also our credential status policy passed. So the credential is not revoked, which is great. But let's now revoke it. And then let's do it again. So we go back to our status Credential Status Service API. And here we have something called status update. Now, what we need to provide here is first of all our config. So when we go back to where we created here our configuration, we copy out our ID, and then we need to update it to be revoked. Now we need the index, which we can also see here in our presentation. So the credential that was issued, status list index. So if we copy out this here, we have our index. Let's update this and execute. So we just updated and revoked the credential with this call. So let's go back to credential/verify. Basically execute the same verification again, copy that, go back to /present. Now we don't go through the whole match credential endpoint again. We just provide here now this URL and execute. So as we can see already, the presentation was unsuccessful. Now when we now go back, sessions.view endpoint, and see what we get this time. We have our VP token. Generally, the verification wasn't a success, which is what we expected. The signature is still true, so that's passed, it's all good. But yeah, so this is true also for the credential itself. But the credential status failed, which is what we expected. So we successfully revoked the credential using the status credential service. And with that, we reached the end of this tutorial. I will link in the description a link to the Quickstart guide, and also, if you're interested, a link to the administrative features section, which is also mentioned here, and the different other services. So you can explore them more in detail, as well as a written version to what we discussed in this video. Like and subscribe if you enjoyed this video. And with that, happy building and see you next time.